Okay, so let's recap what we talked about last time. It was kind of a... Oh, I know what's happening. I'm getting some echo because I've got my monitor turned on in the streaming app. That's a lot better. So last time we kind of got off on a tangent with these permissions issues, and I've been thinking about that, and I think the best way to articulate what was going on there is that in previous iterations of, let's say, generic PySpark, like not Azure Databricks, but just a Spark instance, right? And also generic Azure storage, you could pass in, and let me actually just get down to where we have an example down here. You know, you could pass in a connection string like we were working with this raw path and write to it without needing to make a handshake with the server, because the handshake is taken care of at the authentication side. So like once you passed in this token, you would essentially get back a URL scheme that included the token as part of it, right? And so what's changed and what had sort of slipped my mind is with Data Lake Gen 2 and with Databricks, when you have that connection pass through, the address is basically like saying, hey, you know, this is where I live, right? If you try and walk through my living room wall, you're not going to be able to get in, right? If you try and walk through the front door with no key, you're not going to be able to get in, right? And so what we need is this, going back down here, we need this combination of the raw path and this file system handler, because that's going to use the proper credential pass-through to be able to access our data lake. And so really that's all there is to it. Now, there's a couple other ways of doing this. So I'll just make notes of these down here. I still haven't set up a Git repo for this. Maybe I'll show how to do that at the end of the session. It's another mechanism where you need to use the Databricks command line interface, but it's not too bad. So maybe I'll go ahead and do that. But I just want to point out, so we can use fs dbutils.fs.put. We could use the Azure Blob SDK in Python, or we could use the REST API. Now, if you're interfacing with other code bases that aren't as Spark focused, then the items 2 and 3 may be more relevant. In my world, there's really no reason to never use the Databricks utilities. The other benefit you get from that is as they improve the Databricks runtime and rewrite these APIs, which is happening at a very rapid clip right now, you're going to get performance improvements along with that. So if for some reason there's some sort of runtime speed up for the put command, you're going to get that for free. Okay, so that's storage. So let's go ahead and go back through and talk about what we actually did. So we essentially made a notebook that will ingest as widgets a particular username for Untapped. And then it's going to hit the Untapped API for that particular username and go ahead and ingest all of their data into our raw zone, into a data frame, which we then put in the raw zone. Now, keep in mind, we ran into this issue with a maximum of 300 check-ins. I want to investigate that at some point too, but we've got more than enough data to go ahead and start making our data lake, so that's less of a priority. I'm trying to keep troubleshooting to the minimum. on stream. I think it's a helpful thing to see, but this definitely would qualify as a red herring, you know. So down here, once we had our data frame, which was called full data, you can see up here, then we went ahead and used fsput to go ahead and dump full data as a JSON text string. And then that was what went ahead and made it available in our raw zone. And so once it's in the raw zone, or the bronze zone, as we sometimes call it, then the next step of the ingestion pipeline is going to be trying to get it into a Delta Lake. And a Delta Lake query zone table or silver table. And so if you look at this code down here, essentially this is a 1-2 punch of tasks. So the first thing that we have to do is write out to our file system with the Delta format to this path. And so that's going to create a Delta Lake and a Delta Lake table. And once you have that, for SQL purposes, you can register a new table in the Delta format at this location. And so what's nice about doing it this way is that if we want to do a SQL select, right, then we would, or the show tables command, it's registered with our SQL runtime. And so if we're going to do it all in code, or sorry, all in PySpark code, then this wouldn't be necessary, but I sometimes flip back and forth. Sometimes an expression just comes to you more naturally in SQL. And so I don't know why we didn't get our hard returns down there. Oh well. And so over here you can see when we do a select star from our untapped table, we have a couple different columns here, and almost all of them are nested in the sense that they're complex types. And so our goal today is going to be to flatten some of these out and create query zone tables from each of them that we can use to further enhance our ingestion process. So right now we have this master untapped table. And so the objective is probably going to be to have badges as a table, beer as a table, brewery as a table. And then we'll use these check-in comments, IDs. They're going to be fine. We might have a check-in table too if we need as almost like our fact table with these others being dimensions. I don't think I'm going to mess with comments. I might in the future. So what's interesting here is, well, so first off, I just don't get that many comments. But second off, these are dynamic in the sense that if we pulled this data today and then someone made a comment later this afternoon, we wouldn't have ingested that, right? So what we could do is re-ingest everything and then do an upsert with the new comments, and check the created date. But I don't know how much value that's going to ultimately give us. The media, we're going to handle a little bit differently. So what I'm probably going to do is go ahead and create a folder within our raw zone specifically for images, and we're just going to store. So like if you follow this link, you can see this photo of the beer, right? And so we're going to store that in raw on the data lake with this as the file name, since it's essentially the primary key for that particular check-in from Untapped. And so what that will let us do is in the future, instead of having to reference the Untapped website to pull down images for our Power BI, we would be able to use our data lake instead to support that. And you can see they have a multitude of file sizes. I'm probably going to just grab the biggest and the smallest. We'll see. Rating is already flat. Source, we don't really care about. Toasts, I don't really care about. Maybe it would be nice to pull in, but that's another one. Like, I'm not really using this as a social site. It's more for me. I do have a toast occasionally, as you can see. This one actually came from a brewery in my hometown, which is kind of neat. And then the user should always be the same because it's always going to be me. And then venue is of particular interest. So last time we were looking at that map. One of the things that I'm really curious to do is create that map, but then also use some of these categories like general entertainment or park or outdoors, and use that as sort of a legend within our Power BI visual. I think that would make an interesting grouping. Yeah, and you know, that's really it. So let's go ahead and get started. So I'm gonna begin by probably just exploring this a little bit manually. I think eventually I'm gonna pull in. There are some gists out there, like GitHub snippets that flatten data frames, and I don't really feel a need to reinvent the wheel here. So I'll probably eventually pull those in. But to get started, we've already got our episode 2 notebook, so I'm just gonna pull our configuration cells over there. It's feeling a little slow this morning, I think. Okay, there we go. So again, we can do probably want a space there. Okay, so we're good to go. Oh, did we? Yeah, we used credentials for that last time, didn't we? Okay, 1 second. So I think we need to do our mount point here. Because, yeah, we ended up storing this or registering it at the mount point. Okay, so we'll go ahead and fix that here. So what we want to do instead is if we... Yeah, we should be able to attach here. Okay, there we go. So if we run this here... So what happened is we used the mount path instead of the untapped query path. And so really I want this to be similar to the above, where it's going to be the base path. Okay. Yeah, and then that should be fine because that's our untapped table. Okay, so we'll go ahead and run this. And then down here, so let's try this. So we'll do So with this .sql, you can actually run just raw SQL. But what's nice about doing it in Python is that we can replace, for instance, this location with a variable, which is going to be helpful here. So we can add in our format path, and we can do our query. What did I call that? Oh, it's got an extra slash. Okay. Okay, that looks good to me. And then let's do the same for raw just in case. Okay, cool. Okay, and so down here, let's do it like this then. Okay. So we'll do okay. So we have to mount it, then delete it, then unmount, and then it should be fixed. So let's go back up to here. Okay. Interesting. Okay, so I'm just going to run this all through again. And we'll see what's going on. Oh, I think I see what's going on. At the end of last session, I changed this. This is why documentation and taking notes for yourself is nice. So we're using this core file system instead of the mount path. So that is our problem. So let's see if we can just get away with using our high concurrency cluster. actually, let me make sure of one other thing. Ah, there we go. We need that enabled. Okay. There we go, and I'm going to pick my account. Okay, there we go. Must have turned that off at one point when we were experimenting with all this last time. And now you'll see we should be able to just drop this table immediately. We shouldn't have to deal with any of that mount stuff anymore. We'll see. I think we ended up making a little bit of a mess for ourselves by playing around with that last time instead of just sticking to the credential pass-through. But that's part of the point of these sessions. We got to figure out best practices and maybe get our hands a little bit dirty to remind ourselves why they're the best practices. Forgot that our yeah, this is going to fail because we restarted the cluster. Okay, seems happier this time. We'll see. There we go. And if you look at what that did, we can see it's just walking through doing our drop table commands. And if we look at the visualization here, it's really just looking for all our different partitions within the data lake and making sure that we have them all mapped, and then it goes ahead and drops them after that final exchange. Okay, so now we can register this. Cool. And so if we go ahead and do a select again, okay, cool. So we're in a good spot there. Everything's using our credential pass-through, no more mounting BS. And then, sure enough, over here, okay, and we'll go ahead and have we're going to need to run this parameter script again. I guess if that ran, we don't really care about this. Okay, so this data frame has everything. And you can kind of see its schema right here. And so if I wanted to do a data frame for just the badges, I could do a df dot select, and within that I could do badges, and that's just going to get us this whole struct, right? Okay. But what I really want to do is start walking through this. So what I could do instead is I could do like badges.count. You'll see I get the count, right? But we need to do this for everything. And so really we want to get down to the deepest nested portion of this and then start flattening. So we're going to do a badges dot badges, or sorry, badges dot count, and then we'll alias that as, we can just do count here, and then badges dot items dot element dot lm. It's a little bit early in the day for being able to spell properly for me. Okay, and then badge description, and then we'll do this as let's see if I can run this. Okay, so it doesn't like my alias. Oh, it wants to do, I think it wants to do an as. 1 second. There's like 14 different ways to alias columns, so I always just forget and then end up having to look. So if we do okay, there it is. Oh, and I was going to show last time, sometimes I like to use this tool, Velocity. My license ran out, but it's a pretty neat little documentation lookup tool. And so I'm going to try and start incorporating that a little bit more. There's a free version. It just tends to bug you if you're not paying for it. I don't know if I've shown the cats on the stream yet. There's a cat. Okay, so this is Velocity. So essentially, like, I have Python documentation here. And you can see it's nice and cleaned up. So like I could go straight into the Spark SQL functions module, right? Which we're using all the time. And it's just what's on the website. But what's cool is if I wanted to look up like alias, I could see this alias command for a specific column within PySpark. And you can see what I need to do. If it would actually, come on. We were just there. Okay. I think my laptop is melting on these streams, by the way. So if I do df.age.alias, and so I think we can do that with nesting too. We'll go ahead and try that. So essentially, instead of doing these quotes, we could do df and we do want our single quotes here. There we go. I think I was doing it panda style. So we'll leave that in, and then no such struct field element in badge description. So we did df. Oh, it's, yeah, df badges count, df badges items element. Did I spell description wrong? I wonder if I need to do this. So if you notice, items is an array instead of a struct. And so within a struct, you can, I believe, access these by name, almost like you could in a dictionary. But I think in the array, I might need to either access them by element name using these quotes here, or do a 0. So let's see. This is why flattening is so fun. There we go. Okay, so now we're still in element 0, which is element. This time we're going to do badge ID. I'm going to stick with our naming conventions. Cool. Okay, and then we've got another struct for badge image. Now, this one I'm going to try something a little different. So I'm going to try and use our explode command. And we're still going to do this, except we're going to explode badge image. Come we'll need to import explode. Oh, it doesn't want to explode a struct. Let me see if I'm just using the wrong syntax. 1 second. You might have to walk through it. Yeah, I think we're gonna have to do it the manual way. Let me look at one more thing. Yeah, that's interesting. So it'll work on an array of structs, but it will not work on a struct itself. So one thing I want to see here real quick. And so we're kind of intentionally showing this the slow, kludgy way, and then we'll do a recursive example from that gist I mentioned earlier here in a second. But I kind of want to explore this real quick. So if we instead did an explode on df dot badges dot items, so this is what we'd get back. And so if we did, let's do, so these are all on the same level. Let's bring count and retro status in too, so it has something to explode against. Okay, and so we can see that if we did this, it's flattened everything out into a struct at that level. And so that's kind of what we would need to flatten out again. And so we could, yeah, I think we could use this to our advantage here and make this a little simpler. So I'll go ahead and do that. So let's do, okay, let's think through this. So we're going to create this data frame, which has everything flattened, and to make it easier, we'll call this so we're still going to have items. And so then oh, and one thing I almost forgot that we want to make sure we have on all of these is df.checkin ID. Since that's our primary, or in this case, our foreign key that's going to map to everything else. For badges, I think we're going to have to create a surrogate key to have a primary key. But so basically we can use this struct to then just flatten out the struct, and then we should have everything we need. So let's do that instead. I like where we're headed with that. So I'll just restart down here. Or maybe just clear this out. This is what the videos are for. We don't need the notebook as a complete documentation of every mistake and weird little trail I went down. Actually, I mean, I guess if you guys want that, just let me know. I don't necessarily see the value there. We'll call this df badges, and then oh, actually, I did kind of want, I need this as a reference. While I'm thinking about it, I have not been paying attention to the chat in case anyone's having questions. So let me double check that real quick. Okay, it is just me hanging out today, so that is fine. That's one less thing to worry about. I'm going to move my streaming window over so that I can keep an eye on it, though. And again, if anyone has, if anyone's watching these on Mixer and has questions after the fact, you're more than welcome to pipe up then. It's not like there's a time limit on when you can ask questions or throw out ideas for future sessions or anything. Okay, so we want to do .select and a lot of this is going to be the same as before, so I'm just going to steal the code. Okay, so df okay. Okay, and so then within items, so items is a struct now, so we should be able to do df badges dot items dot, and we'll do badge description first. I think I already have this on the clipboard. There we go. Badge description. Okay, where is it? Unhappy. Let's actually go up through here just to make sure. Okay, it might be this, or the whole thing. Let's see. Okay, so it's not that. Badges.count. Oh, count is, I forgot, it's a reserved name because of SQL. So we'll leave this as badge count. Doesn't roll off the tongue as easily and makes me have to type 5 more characters, but we'll live. Bam. Okay. There was our problem. And I don't think anything else is going to be reserved. So, okay, sure enough. So our strategy here is going to work fine. So let's just keep moving with that. And I know that it is just thrilling to type all this out, or watch me type all this out, but this is kind of what a lot of the data engineering stuff looks like. And that's why I want to show the automated piece next. And crap, we might not have time today. We'll see. But you know, once you do a few of these, it can just be pretty exhausting to do manually. So you start to write out code to write code, and that's always ends up being more productive for me, at least. Okay, so we'll do. And really, I don't need the show here. I just need the column name. So I'm gonna clean this up a little bit so I stop having to scroll. There we go. Okay, so we do badge ID, or items, badge ID. So now we want to do badge image. Okay, badge image, and then that's going to be dot large. Okay, and then So still within items, it's going to be badge name. Not large name, just name. That's interesting. I don't actually know what user badge ID is going to be used for. So I'm going to probably just leave it alias the same. Okay, and let's go ahead and do a show. Actually, this is worthy of a display. Cool. So you can see our nice little flattened structure here. And so what I'm going to do now is take df badge is flat. Yeah, df badge is flat, and then we'll do dot right. And we could stream this out. I don't want to get that fancy yet. We'll do a right, and we'll do a format of delta. And then if we take our code from episode 1. Where is it? Yeah, dot save. And then we're going to need to create a new query path. That's the piece I wanted to point out. So and at some point we'll talk about maybe how to parameterize these notebooks so that we could use the same code to say flatten and write back out all of these tables. That's, best practices. For now, we're kind of, again, just doing the messy work, doing it by hand, sort of looking at what that entails. So we'll do this as untapped badges. And actually, one second. Okay, so we're doing query. Okay, yeah, we'll do untapped. I really probably should have created a separate folder for just the untapped stuff, but we could worry about that later. That'll be just an example of how to use the move functionality. And right now we've just got one data set in place anyway. So we'll make this untapped badges. Cool. And then down here we can do dot save. And we'll do untapped. Sweet, and then I'll steal my Spark code, wherever it went, right here. And we'll register this table. Okay, cool. Okay, so now I want to look at using that gist real quick. So if I do okay, yeah, I think I've got the link up. 1 second. This is one of those things where like everyone and their brother has an idea of how to do it, so I'm just trying to find the one that I prefer. I think we got a case of programmer's shoulder coming on. Need to do more yoga today. Okay, I think I found it. Okay, and so I'll bring that over. And another thing I want to show in a second is I forgot to talk about using your Delta Lake to manage your schemas as well. So we'll look at that. Okay, so I want to put this in a new notebook. We'll call it helpers, or let's just call it we've already got parameters, so functions is fine. Okay, cool. So let's make sure this runs. Great. So now over here, also run utilities / functions. Oh, you can't do more than one at a time. I always forget about that. I think I literally forgot about that last time. The magic commands are really handy, but they're still a little bit terse. Okay, so let's down here do df flatten. I think it's called flatten df, and let's just pass in our df.select and we'll do df.badges. We'll go ahead and show this, or I'll do a display. Okay. Did I really not? Oh yeah, sure enough, I did forget my import. Oh, it's... Need more coffee. From PySpark.sql.functions. Import call. There we go. Okay, and so this did part of the nesting for us, not all of it. So I can poke at that a little bit. I think it's making some assumptions about our data that maybe aren't as fair. So let's give it something a little bit more challenging. Let's try and do, and it might also be the level of recursion. So we could do. Wait, we want to do. Oh yeah, okay. So if I do display, yeah, so we should be able to go into, oh, it's df, yeah, df.badges.items. Okay, weird. Interesting. But if we go back up here, so it's, yeah, it's just badges.items. Okay, let's see. So if I do df.select, okay, and then if we do this, that's probably what it is. So if I do interesting. So I don't think it likes the fact that items is an array, maybe. So I'll play around with that. I think this random piece of code off the internet might need a little bit more inspection first. But one thing that we can always do is this. So it's expecting this to be called nested df. So we can just say nested df equals that. Then we can sort of follow it through. Yeah, see, so it likes that. And then what I think it's not going to like, yeah, and so it decided it should be stack equals 0.nested parents equal. Yeah, I think it's expecting a struct here. That's fine. So our manual process is going to work fine. And then where this would really shine is down here. I'll go one level deeper and do the struct. So if I had done badges, .items, .elements, or .element, oh yeah, okay. It took over our name there. That's fine. So we can use this to reload it. So if we do this. So if we walk through and we do df badges items, oh, it's the index issue again. And you can see the untapped API has some nasty conventions for the way that it's passing through data. It's not quite using pure JSON like it could be, but oh well. I don't think they ever expected someone to be poking around in their stuff like this. Let's alias this. Excuse me. Okay, let's see if it likes this. There we go. So you can see then if we took this return statement, which I left out. So this is kind of our df is like our stack. It kind of holds the deepest nested level. And if you think about it, this is the deepest nested level. So that kind of makes sense. And if there's interest, I can walk through this little algorithm. But it really is just kind of like a recursive walk through. So let's display this. Okay. So you can see that. And so really what we would maybe want to consider doing is doing this just for like items, for instance. And then for every instance of items or from the outer array, we could kind of stitch it together. And so, and I'm probably not going to fully pursue this, but if we went back up and did, if we re-import the df, and I'm going to go ahead and just borrow this code. So if we did if we did df.badges.count, actually we already have code for this too. This is really just what we're doing for this. Yeah, so really it's just df badges, I guess. So I was already kind of a step ahead of myself. So if we try and do df nested equals df badges, and then we can do, I think there's a copy command. Oh well, we're not going to worry about deep and shallow copies right now. So we can do this, and then we can run this, then we can run this, and that gets us our flattened data frame. And if we compare the equality, okay, and that is dot equal. So if we were to do so we could do df badges flat dot equals, or is it, I think they changed the name of it. Oh, yeah, sorry. We can do subtract. And if we subtract temp and we get back something empty, then we know that we're good to go. Okay, and so we're not getting an empty frame, but the sorting could be an issue here. Let's see. And we don't have and we don't have the unique primary key. Now, the primary key plus the badge ID number should be unique. So one of the things that I missed from Pandas that I don't think exists in PyCharm is just an equals operator, and it checks at the column level. I think in Databricks it would just be pretty expensive. So let's do this. Yeah, I really think this might just be a sorting issue. So let's do that real quick. So if we do I don't even think I need an extra cell for this. I'm just going to do it in line. And you know, honestly, I might have not even thought of it. The column names in the order of the columns could impact it too, but I kind of just want to see. So this is temp. Okay. Yeah, I think it's the column name issue. So let's do with column renamed. Okay, and so we're gonna take so check-in ID is cool. Badge count. This needs to be description. I have a funny feeling. I don't think you can chain these together, but we'll see. Oh, sure enough. That's nice. Okay, and we'll do item badge name. Okay, I think this should do it. Okay, and then the order matters too. So let's do. Oh wait, does order matter? We'll see. This is going to want to be called time now, I believe. Should be want to call time. Okay, yeah, I think our order is still going to matter. So if we do come on. I really don't want to mess with Markdown right now. I just wanted to keep my hard returns. And Spark Markdown is kind of weird. Yeah, of course. Okay, what if I do... There we go. Beautiful. So if I do tmp equals tmp.select, and I think there's a way to alphabetize your columns, and I could probably just do that, but we'll just do check-in ID. Badge ID. Okay. There we go. Okay. And we'll go the other direction too, just to verify. But so what we've effectively proved is that this fun, painstaking work we did up here, manually traversing and renaming and accessing all the columns, we can effectively do as long as we explode our array. I did not mean to click that. As long as we explode any arrays in here, and then we can use this pretty generic flattening code. So what's neat about this code is this is actually it's the same code that you would use to flatten a dictionary in Python. We're just using some of the underlying Spark type definitions within the data frame, like the struct type, to control our navigation, and then we're using a data frame as a little stack. But so this is pretty generic code, and we can see that if we for instance, next time going to this beer struct, we can go ahead and use it to flatten all these other tables. And so we've now created a, where's my code for that? Up a little bit, sorry. We've now created a delta table for untapped badges. And so next time we'll go ahead and create that for beer and everything else and keep that going, but we'll use the automated version. So that should only take about 10 or 15 minutes. And then we'll start moving towards creating some of our sanction zone tables, our gold tables. These are essentially queries against the query zone or silver tables that give us our user insights. So like we might want to have something that, you know, aggregates or summarizes some of these underlying tables. So that's the plan. Thanks for tuning in today. As always, reach out if you've got any questions, and please sign up for the Valorem Databricks user group. We've got ML Flow happening on the last Tuesday of this month, and then we'll be summarizing the Spark Plus AI conference in the last Tuesday of July.